Hello students, welcome again to another session of electronics. Today we will continue to discuss second chapter, Principles of Electricity. Okay, if we have to recall what we did in the previous class, we talked about what is the magnitude of charge on a single electron, which is 1.6 into 10 to the power of minus 19 coulombs. And we also talked about definition of current, which is charge by time, or it can also be expressed as number of electrons into magnitude of charge divided by time. And we also talked about potential difference or voltage, which is nothing but work done in moving charge from one point to another. So V is equal to W by Q. From Ohm's law defined that current is directly proportional to voltage provided physical conditions and temperature are constant. So from that Ohm's law we have the equation V is equal to IR, or this can also be expressed as I is equal to V by R transposing, and also R is equal to V by I. These equations are important for solving problems. Today we are going to use all of these. And we also talked about resistors in series and resistors in parallel. When resistors are in series, all you do is add them. If two resistors are there, you add them. If two resistors are in parallel, you take reciprocal of addition. And 1 by Rp is equal to 1 by R1 plus 1 by R2. You take LCM, and then Rp can be expressed as R1 R2 divided by R1 plus R2. When two resistors are in parallel, this is the equation. It is better you learn it by heart. This is for two resistors in parallel. This is for two resistors in series. Series is not a problem. If there are n number of resistors in series, all you have to do is add them. If there are n number of resistors in parallel, all you have to do is add reciprocal of them. Then you will get the answer also in reciprocal. You have to take, for getting Rp, again you have to take reciprocal to get the answer. That you should remember. Okay. Now resistance is always expressed in one of these forms. It could be in ohms or kilo ohms or in mega ohms. What is kilo ohm? Kilo ohm is 10 to the power of 3 or 1000 ohms. Mega ohm is 10 to the power of 6 ohms. So invariably for most of the problems we use it as in ohms or in kilo ohms. So I want you to remember all these. Today we are going to solve some problems also later. Okay, and today what we are discussing is power and energy of electricity. So let us first take what is electric power. Power is defined as rate of doing work and is measured in watts. So rate of doing work means the expression can be work done by time or energy supplied by time. So if you write energy or work done as W, time as T, then P is equal to W by T. Just multiply and divide by Q, then you can rearrange it as W by Q into Q by T. But we know that W by Q is what? Just now we recalled what we discussed in the previous session. W by Q is nothing but voltage or potential difference, and charge by time is nothing but current. So power is nothing but product of voltage and current. This is a very important expression. What is power? Power is product of voltage and current. Okay. So now if you substitute from Ohm's law for V is nothing but I into R by Ohm's law. So then it becomes I squared R. If you substitute for only I, then it will become I squared by R. That is what we are going to discuss next, to see how much power is dissipated in resistor. See, power dissipation in a resistor. When you use an appliance, any appliance if you use, you must have seen it gets heated up. Okay, that is because the electrons will be bombarding in the appliance when the current is flowing and the device gets heated up. So we calculate that as power dissipation in a resistor in the form of heat. So we have the equation V is equal to VI. So you substitute from Ohm's law for V, which is IR, it will become I squared R. P is equal to I squared R. Or if you substitute for V by R, then it will become V squared by R. So we can have power as in three expressions: product of voltage and current, or I squared into r or v squared by r. Whichever parameter is given, you can calculate the power. That is the whole idea. Okay, remember these equations, we will use them again in problem solving. Next, how to calculate electric energy. Electric energy is the amount of power supplied or consumed in certain duration of time. Okay, so how do we understand this? You are getting power supplied to your home by electricity board. KB supplies power. So you are utilizing that power for certain amount of time. For example, if you are burning tube light, if you are using tube light for 7 hours a day, then if the tube light's power rating is 40 watts, you are using then the tube light is used for 7 hours, means that 40 watts into 7 hours become energy consumed by you. That is what is electric energy that we are talking about. So we have the electric power P is equal to W by T, energy by time. So energy consumed is nothing but power into time. So that is the expression for electrical energy. Okay, so electrical energy is defined as P into time, where P is in watts, T is in second. That time we will say electric energy is in joule. But joule is small, so what we do, but we are not using things in seconds, isn't it? We are using it in hours. So what is 1 watt hour? 1 watt hour will be 1 watt hour can be written as 60 minutes, and each minute is 60 seconds. So hour is nothing but 60 into 60 seconds, or 1 watt hour is nothing but 60 into 60 is 3600 watt seconds. Watt second is nothing but joule. Joule is the SI unit of electric energy. Okay, so what is 1 watt hour? In terms of joule, it is 3600 joules. Now that is also a small unit. 3600 joule is a small unit. So commercially we use, commercial unit of electrical energy is 1 kilowatt hour. So this is the amount of electrical energy consumed when an electric appliance having a power rating of 1 kilowatt hour or 1000 watt is used for 1 hour. If any appliance of 1000 watt rating is used for 1 hour, then we say that 1 kilowatt hour energy is used. So 1 kilowatt hour is called commercial unit or board of trade unit, or simply 1 unit. So we can write 1 kilowatt hour as equal to 1000 joule per second into 60 by 60 second, or 1000 into 3600 joules, or 3.6 into 10 to the power of 6 joule. This is nothing but 1 unit. So you can go back and see. You can take your electricity bill which you get every month. In that it will be given how many units you are consuming every month. Okay, depending on you're using TV or dishwasher or washing machine, microwave, so many bulbs, everything in your home, based on for how many hours you are using these appliances, number of units will be generated. And there are different slabs also. Based on the slab, unit rate will change. Unit rate may be initially maybe 5 rupees per unit. Later on it will increase as you are consuming more and more units. So you can just check your electricity bill. You will be able to understand what unit we are talking about and how much of energy you are using in your home and why so much of electricity bill is coming for you. Okay, that is commercial unit of electrical energy. This is generally how much of unit each device consumes. For example, a refrigerator uses 4.8 kilowatt hour per day, that is 4.8 units, whereas a freezer uses 6.6 units per day, and ceiling fan uses 1.6 units when it runs all day, and air conditioner uses 7 to 10 units if you use only 2 hours. That is so much. So you can imagine, if you want very cool home, then you are going to consume lot of energy. And it takes 3.9 units for washing machine, and it takes 9 units for your geyser or water heater. This is generally for your awareness. Next we will take some problems. Okay, so the first problem is find the power consumed by a cell phone when operated with 9-volt battery and 500 microamps of current. So what is asked? You have to find power, and voltage is given, current is given. What is the equation for power relating voltage and current? We have P is equal to V into I. V is given as 9, current is given as 500 microamps. So multiply these two. 9 into 500 is 4500 microwatts. Units are very important in electronics. We have many units, you have to learn them all. Power is in watts, right? So you have to write 4500 microwatts. If you write this is for 2 marks question. Second question, specifications of an iron box are labeled as 230 volts, 350 watts. Calculate the resistance of the iron box. So what is given? Given is voltage as 230 volts and power as 350 watts. We have to find resistance of the iron box. How is power, voltage, resistance related? Just now we derived that power is nothing but V squared by R. So we need R. So transposing, R is equal to V squared divided by P. So substitute for V, 230 volts whole square divided P is 350. Simplifying you get 151 ohms. This is the resistance of iron box. Okay, you can also look at each appliance in your home. There will be rating written. What is the voltage? What is the power rating of the device? Your iron box or your computer or your television, at the back it will be written. Okay, and even in your charger also it will be written what is the current rating also, what is the voltage that it is giving out, what it is taking in. So now that you are electronic student, you should just look around and see for the rating. It will be interesting. Let us take the third problem. An UPS. What does UPS stand for? Uninterrupted power supply. Many of you may be having at home. UPS supplies 2 amps of current to a bulb of 12 volts for 5 minutes. Calculate the amount of charge supplied by the UPS. So what is given? Current is given, bulb voltage rating is given, and for how much time it is used is given. Now what do we have to find? Charge we have to find. Equation for charge is I is equal to Q by T, current is equal to Q by T, or Q is equal to I into T. All these equations I told you in the first slide which I have shown, all are important. You should learn them and then you can use. Q is equal to I into T. So what is I? 2 amps. T is given as 5 minutes. But we have to always use in seconds. So 5 minutes means here I have converted, minute. Each minute is 60 seconds. So 5 into 60 if you do, you will get it in seconds. So then it will become 2 into 300 equal to 600 coulombs. Again, charge's unit is coulomb, you have to write. Next, what is the total resistance between A and B for the following circuit? 4 resistors, how are they connected? They are connected in series. So what are the values of the resistance? First one is 100 ohm, second is 300, 450 ohm, 600 ohm. What should we do when they are all connected in series to find the total resistance? You should add them. That's all. If you told that, very good. See, RAB is equal to R1 plus R2 plus R3 plus R4. Add them all. Then you will get 1450 ohms. Or if you have to express it in kilo ohms, all you have to do is divide by 1000 and write it as kilo ohms. Divide by 1000 becomes 1.45 kilo ohms. Okay, next problem. What is the total resistance between A and B for this circuit? Given R1 60 ohms, R2 30 ohms. First of all, you should understand how the connections of the resistors are. In this case, they are connected in parallel. Correct? So when they are connected in parallel, what is the equation? Equation is R1 R2 divided by R1 plus R2. So substitute for R1, substitute for R2, which is 60, 30 divided by 60 plus 30. 60 into 30 is 8800, 60 plus 30 is 90. The division will give you 20 ohms. So when two resistors are connected in parallel, it is better you remember this equation. Always it's going to be helpful. Okay, R1 R2 divided by R1 plus R2. We'll take the next problem. What is the total resistance for the following circuit? Now how do you see the circuit? We have 1, 2, 3, 4 resistors connected in this fashion to a power supply, DC supply. Okay, so we are only they have only asked total resistance. So we are only worried about calculating the total resistance from here to here. You should now understand that these two resistors are connected in parallel. Correct? So when they are connected in parallel, first you should simplify this parallel combination always. First you should simplify this into one single resistance. Parallel combination becomes one single resistance of value. What is the value for parallel combination? What is the equation that we use? Just now we did for this previous problem. Parallel resistance is R1 R2 by R1 plus R2. So in our case, what is R1 R2? 6 into 6 divided by 6 plus 6, which is 36 by 12, is equal to 3 ohms. These two parallel combination can be represented as single resistor of value 3 ohms. Rest of them you leave as they are. You need to keep drawing like this for simplification, only then you will get it. Parallel combination should be converted into single resistance of value 3 ohms. This 3 ohm, this 5 ohm remains as it is. Now how do you see these three resistors are connected? They are all connected in series. How to recognize if they are in series or parallel? When they are in series, same current flows. See, if it starts from here, it flows like this. So that is when you decide the resistors are in series. How do you know they are in parallel? For example, if the current is coming here, I goes here, and at this junction it divides. It has to go here also, it has to go here also. So when there is division of current, then you will say that they are in parallel. It divides here also, and they join here and come here. Same current what flowed here comes here also. So then you will say that this and this are in series, but these two are in parallel. When you convert the parallel combination into single resistance, now you saw that the same current flows through all the resistor. That means all the three are in series. When they are in series, what do? All you have to do is add them all. 3 plus 3 is 6. 6 plus 5 is 11 ohms. So this can be replaced by one single resistance of value 11 ohms. This simplification of resistance, 4 resistors into one single resistance, is important. We do it a lot in electronics, and it's very simple. All you have to do is observe the circuit diagram and recognize which is in parallel, which is in series. If the current divides, then they are in parallel. If same current flows, then they are in series. Okay, you should remember this. Now we will take one more problem here. What is the total resistance and total current for the following circuit? So in this circuit, what do you observe? Which is in parallel, which is in series? And what is happening? Now 4 ohm is connected to a combination of 6 ohm and 3 ohm, and they are connected to the power supply. Which is in series, which is in parallel? These two, do you recognize they are in parallel? Very good. If you can recognize, very nice. So first we should simplify this into single resistance. So when two resistors are in parallel, the equation is R1 R2 by R1 plus R2. So substituting 6 into 3 by 6 plus 3, we get 2 ohms. Now this can be replaced by one single resistance of value 2 ohms, and that is in series with 4 ohms. When two resistors are in series, what do? Total resistance we are going to add. 4 plus 2 is 6. So total resistance is going to be 6 ohms. Total voltage is going to be 24 volts. So how to calculate current by Ohm's law? I is equal to V by R. R is 6, V is 24. So total current V by R is going to be 24 divided by 6, which is equal to 4 amps. This will be asked for 3 marks. Okay, so first, what is the job when they ask for total resistance and total current? First, simplify the resistance combination to a single resistance value, seeing which is parallel, which is series. First parallel you should simplify, and then you add it to the series resistance. Once you know the single value, final value, total resistance value, then total voltage by total resistance will give you current. They can also ask total power also. So how to calculate total power? P is equal to V into I. V is 24, current is 4 amps. 24 into 4 is going to be power. That also you can calculate. That can also be given. That at that time it will be for 4 marks. Okay. So this is the 7th problem. Each problem take time. You can pause, go back and see and understand thoroughly. These are basics. If you get your basics strong, then you can solve any other problem later. And same things are there in your second PUC physics also. So please pay attention and learn properly. Next, we'll take up 8th problem again to find total resistance, total current for the following circuit. You have to analyze the circuit and see, first find out the value of total resistance. To find the total resistance, you should understand which is in series, which is in parallel. So how are they connected? Resistance R1 is here. If the current is flowing from here, it gets divided. And again same current flows here. It joins and same current flows. That means these two resistors are in parallel. So your job is first to simplify this into a simple single resistance. When two resistors are in parallel, the equation is R1 R2 divided by R1 plus R2. So 4 into 4 divided by 4 plus 4 is 16 by 8. This can be simplified as 2 ohms. 16 by 8 is 2 ohms. Now this is 2 ohms which is here, and all the rest of the resistors are here. So how are these connected? They are in series. So what is the total resistance now? 2 plus 2 plus 6, which is 10 ohms, correct? 2 plus 2 is 4, 4 plus 6 is 10 ohms. So if it becomes 10 ohms connected across 12 volts, what will be the current then? 12 volts divided by 10 is the current. Shall we write it down? Let me take a pen. Then total resistance in our case is going to be 10 ohms. And what is total current? Total voltage is 12 divided by total resistance. What we calculated is 10. What is 12 by 10? Equal to 1.2 amps. This is the total current. They can also ask for total power. How to calculate total power? V into I. What did we do for voltage? What is the total voltage given? 12 multiplied by total current is 1.2. What is 12 into 1.2? It's actually 14.4. What is the unit of power? Watts. So 14.4 watts is the power. This is how you calculate for power. It can be asked. This will be asked for 3 marks. To find the total resistance, to find total current, and to find total power. Okay guys, please go through each one in detail, try to understand, and then you will be able to solve other problems also. So I have given assignment for you like this. You have to find the total resistance, same as how I showed you earlier. You have to find the total resistance and total current for this one, and also you have to find total resistance for this circuit. Already I have put it in a simplified circuit. You need to draw all these. Each time when you draw, your symbol drawing will become perfect. Okay, so you please draw and practice. Symbol of voltage source, symbol of resistors, they're all important. Solve this problem also. I am going to leave you today this session with this thought. Aristotle, famous philosopher, told, roots of education are bitter, but the fruit is sweet. So when you're learning new things, you should not be lazy. It's going to be tough. If it is tough initially, that means it is going to be good eventually. That you should remember. So if the concepts are tough, as we are going deeper in any subject, it is going to get tough. But you should not give up. You should work hard. You should practice. Then things will fall in place. You will be able to learn better and better. Okay, so that is what is great philosopher Aristotle, whose words have value even today and forever for sure. So we will I want you to think about this and keep practicing. I will see you in the next session. Take care. Bye bye. Thank you guys.